Quiz is postponed to tomorrow. Yeah. I posted an announcement. But apparently everybody doesn't get the notifications that there's an announcement. Okay. All right. Questions about so what we're gonna do, we're gonna build on this today. You got a question? Yeah, which one? 12. All right, so everybody flip over to 12. That means I need to scratch the paper that I have anything to write with and write on that time. I'm sure. What's it say? No. All right. So number 12, y equals negative 3x minus 4 times x plus 2. What's the form? Intercept form, right? What are my two intercepts? I need to average them together so that I can find the axis of symmetry and then plug that in to find the vertex. So my axis of symmetry is going to be 4 plus negative 2 over 2, which is 2 over 2, which is 1. Thank you, 1. Now if I plug that in, I get negative 3, 1 minus 4 times 1 plus 2, which is negative 3 times negative 3 times 3, which is 27, right? So you might not have had enough lines on your graph or whatever. You might have to go by 2s or 3s or whatever it is. But when you graph it, should up and down, right? Yeah. Bless you. I'm going to go by 3s. 3, I need to go to negative 2. And then 3, 6, and positive 4. And then I'm going to go 1, 3, 6, 9, 12, 15, 18, 21, 24, 27. There you are. What else from your homework? Good? I didn't figure there'd be a lot since we worked together. Yeah, 15. Let's see. Oh, 15 is a good one. Y equals negative x plus 2 times x minus 1. So I'm intercept form again. What are my two intercepts? Negative 2 and 1. I need my vertex, so to do that I'm going to find my axis of symmetry first. And I'm going to do negative 2 plus 1 over 2, which is negative a half. And then plug that in to find the y portion. So negative 1/2 plus 2, negative 1/2 minus 2. 3 over 2, negative 3 over 2. No, it's not 3 over 2. Yeah, 1.5. Should be getting the same thing. What did I do wrong? Negative 2 plus 1 is negative a half.
It's minus 1, not minus.
Thank you. I knew I did something wrong. There we go. So this becomes 9/4. You're a decimal person, that is 2.25, 2 1/4. Why do you keep looking at Logan like that? He's giving you signs? What kind of signs is he giving you? Like sign language? When I graph this 1 and negative 2, I'm at negative a half for my axis of symmetry and up to 1, 2, a little past that. Yes, no, maybe so?
Yep.
Anything else? Homework? Once Twice? All right, let's talk about domain and range then. Y'all ready? Hold on to this because what I'm going to have you do is go back before you turn this in at the end of the day and add all the domain and range on here for all of these. I know that sounds like such fun. It won't take long and then I'll take this up from you. Yeah. I'm going to have you physically turn it in instead of submitting online. I changed it this morning. I forgot. I didn't mean to make it online. So yeah, it's okay. And I deleted everybody's 0 that was on there. All right. Switching gears, so you need your notebook. So domain and range is probably something you've seen before and you've done before, but I'm going to teach you a new way to do it. More sophisticated way. Tell me what domain means. X. It's everything that X can be whenever we graph something, but it describes all of the X's. You're exactly right. Which means range describes Y. So if I'm in a t-chart or something like that with a discrete function or something that just has several points, it's easy to determine the domain and range, right? Because it's just all the X values and all the Y. Go ahead. I'm loud. I can talk over it. But whenever I'm talking about a graph, it's a little bit harder to describe, right? I'm going to just put the vertex here on 0, 0. I'm going to just do a parent graph. This is the graph of X squared. Looking at that graph, what do you think the domain here would be of this graph? In other words, what are all the X's that could be on the graph? All real numbers, yes. We talked about that a little bit yesterday. I mentioned it, but I told you we talked about this more. If that doesn't make sense to you, let me show you why. As I look on here, is there ever any place that I could go where there's not a corresponding X value on the graph? In other words, if I come all the way out here, is there still a Y that goes with that X there? Could I find a Y value for this X value? Yes. It's going to be super high, right? But it's still there because at the end of the day, these edges are kind of creeping out forever and ever. So my domain, I say, is all real numbers. I'm fixing to teach you the symbols for all this. We're going to write it a new way. That's for real numbers, but we're not going to use that. That's a baby way to do it. We're going to talk about the new way to do it. The more sophisticated mathematical. But for right now, I just want to refresh you on domain and range before I show you the new notation. How about range? Range is everything Y can be.
It is Y less than greater than.
There you go. Explain why, Logan.
Well,
That's exactly right. So I always tell students for domain, we're looking left to right. And for range, we're looking from the bottom up. Okay, so the lowest up to the highest, and range and domain is left to right. Okay, so as you read it, that's what we're looking at. So the lowest the graph ever goes here is 0. Remember my y-axis, my y values. The lowest it ever goes is 0, and then it goes up forever. So y has to be bigger than or equal to 0. Everybody okay? Y'all remember doing this? Domain and range? Speak now, forever hold your peace. You could have negative numbers. So if it opened, let's say that I had a parabola that looked like this. What's the domain? All real numbers. In fact, for all of our parabolas, the domain is all real numbers. How about the range? That's an A. Y is, say again, less than or equal to, because it's all everything below up to 2, right? Does everybody see that? So the Y value, these are your Y values, right? I'm looking for where there's graphs. So I kind of take my hand like this and I go, okay, what's the lowest the graph ever goes? It goes down forever, right? And then as I come up with my hand, does it ever stop? Is there ever a place where the graph stops? Well, it stops right here. It doesn't go past that point. So that means it's on the y-axis, it's everything smaller than 2. So that's why I say less than or equal to 2. Y'all okay? What's the domain? Give it to me. What do you mean 3 and -3? Yeah, it could be 3 and it could be -3. What are you saying? That's all it could be? Okay, how do I say that? You're right.
Yeah.
Like remember doing those compound inequalities like that? No. This just says that x can be -3 up through 3 and everything in between. It's sandwiched between those two numbers. We think the range is. Range is the same thing. That's exactly right. Because from the bottom, it doesn't go below here, and then it's up, and then it's here, right? It doesn't go above it. We're going to practice lots of domains and range. Let me show you how we write it now. So I'm going to kind of digress from domain and range, talk about inequalities for just a second, and come back to domain and range. So if you're confused, it's okay. Domain and range always stumps students for some reason. But we will get there. All right, so what I'm going to teach you is I'm going to take inequalities like this. This is actually an inequality, you just haven't written it yet. And I'm going to show you how to write it a new way. This is what we call interval notation. It is the most accepted way to write inequalities when you get to this level in math. And we use it all the way through calculus and beyond. So I think the easiest way for me to describe this is if you think about a number line. Thank you. Let's think about one of those inequalities. Let's use x because everybody likes x. Let's say x is greater than or equal to 0. If I think about this on a number line, here is 0. How do I graph this on a number line? Now you got to go way back. So what kind of dot? It's a special kind of dot. It's a closed dot. Why is it closed? That's right. Because of this line under here that says include 0. So to indicate that, I fill this circle in, right? And then I need to graph it which way? Why? This says greater than, right? Greater than means get bigger. Which way do the numbers on a number line get bigger? That's right. Okay. So I'm going to show you how, well, actually first, how do we describe mathematically really, really, really big forever and ever this way? Infinity. I'm going to say that this way is infinity. Have y'all seen the infinity symbol before? I'm sure you have. All right, and then this way then would be what? If this is infinity, this would be negative infinity. All right, now here's what else I'm going to tell you. If this is just x is greater than 0 instead of greater than or equal to, how is that different on a number line? That's right. It's an open circle here because it can't actually be 0, but then everything else is the same, right? All right, so with interval notation, here's what I'm going to tell you. If it's or equal to, so if it includes this way, I'm going to use a bracket to indicate that. Let's see, greater than. So I'm going to use a bracket. If it's just greater than or less than, I'm going to use a parenthesis. And I know this is confusing right now, but you will see. Interval notation is nice because it literally just lists an interval of numbers and it tells you where to start, where to stop, and then the brackets and parentheses tell us what to include and what not to include. So now if I go back to this x is greater than or equal to 0, always start smallest, let's see, I'll do a bracket or a parenthesis, whatever, and I do the smallest value, I do a comma, and then I do the largest value that it could be. And then I do a bracket or a parenthesis, whatever is applicable in the problem. So if I look at x is greater than or equal to 0, and I want to write that in interval notation, what is the smallest that x can be? 0. We agree? Is it included or excluded? In other words, is it a bracket or a parenthesis? A bracket, right? Because if it's underlined, it's a bracket. So I'm going to do bracket, comma, and then I keep going forever and ever and ever. So it's the biggest infinity. So I'm going to put infinity. Now, can you actually be infinity? You can't actually, infinity is conceptual, right? There's no actual number. So infinities always get parentheses. So x is greater than or equal to 0 is exactly the same as saying bracket 0 infinity parentheses. That is interval notation. It'll be confusing at first, and once you get it, you'll go, oh my gosh, I never want to go back to inequalities again. Oh, yeah, sorry. Sorry, change that. Thank you. Thank you, I appreciate that. Infinities always have parentheses, yes. Let's do another. X is, we'll do another greater. X is greater than 5. Write that in interval notation. I just want you to write it in interval notation, like with parentheses, brackets, whatever you need. If you need to picture it on a number line, sketch a number line and look at it. Sometimes that helps you see what's the smallest, what's the biggest. If x is bigger than 5, what's the smallest that x can be? 5. Can it actually be 5? No, so I need a parenthesis. Then I do a comma, and it goes up to what? Infinity, right? It starts at 5 and it goes to infinity. So this is 5, x is greater than 5. That's all you got to do. Now it gets, we're going to get a little bit, yep. How about x is less than or equal to 2? Don't say the answer when you get it. Well, I'm thinking about it. I won't be here Friday, but I'll leave y'all something to do. I know. Sad of me. I doubt it. Mr. Smith will be in here with you. No. How many of you think you got it? Anybody else? You got it? Anybody else? No, I was in it. I didn't.
You got it.
the smallest I can be? Parenthesis or bracket? Oof. Now I go up to what? Bracket or parenthesis? Does everybody see why? Yep. So if I am, why it doesn't matter what the variable is, it's still the same. If I'm at 2, I'm a closed dot, right, because it includes, and I'm less than, so it goes this way. So the smallest I can be is negative infinity. Yes. How about this one? Y'all ready for this? I'll change the variable here. Write that in interval notation. Remember what interval notation does. Smallest to biggest. Put it on a number line and look at it. Might be easier to tell. No. In fact, you're not even going to have homework on that. You'll just be writing domain range in interval notation. What's the smallest y can be? With a bracket. That's exactly right. Then it goes up to what? 3, and it stops with a parenthesis. All right. Are we seeing how this is working? Because I'm fixing to add something else to it. You guess? Unfortunately. But we are, oh my goodness, Stacy, talk. All we are doing today is the main one. Do you remember OR problems? What if I need to describe something like this in interval notation? You just don't. Okay, so let me tell you this. As you write an interval notation, there may be times when you need to join two intervals together. Okay? To join two intervals, I don't know why they stopped teaching intersection of sets and union of sets, but they did. To join, yeah, but you didn't learn intersection and union, and that shows up on standardized tests still. This or this of sets, where do they share the same thing, or you put everything together and every? I know you don't learn it anymore. I don't understand. Okay, to join two intervals, all we do is we combine the intervals with a U in between. Okay. So in other words, if I have some space like this, I've got all this dead space, right? But I need to combine it with the other end. I'm going to use a U. So let's walk through it. What's the smallest I can be? Negative infinity. And I need a parenthesis because infinities always get parentheses. And then I go up to what? -3. Bracket or parenthesis? Bracket. And now I stop, but I pick back up. I've got some more I need to include. So to include that, I'm going to put a U so that it joins with another interval, and then I'm going to pick up at 2. So I'm going to do a bracket or parenthesis. Up to infinity with a parenthesis. So this says start as far left as you can get. Keep trucking until you get to -3 and stop, but include -3, but stop there, and then pick back up at 2 and keep going forever. Yes. Or when it looks like this, that's a bracket. Yes, yes. But you won't have a number line like this. You'll just have an inequality. Well, you'll just be looking at the graph to tell. What if, for whatever reason, there's just one number you need to leave out? Let's say I want to be everything on a number line except for the number 1. I'm going to put an open circle on number 1, and I'm going to say I go forever this way and forever that. I want to be everything except 1. I want to be 0.999999 and 1.0000001, but I don't want to be 1. How can I write that in interval notation? What's the smallest I can be?
1.
Negative infinity. Up to 1. Look, I stop at 1. Do you see that? See that stopping point at 1? I stop at 1, and I don't include 1. So what do? Parentheses. Now I got a little dead space. Even though it's just 1 point, it's still some dead space. So I need to join it with something else. What do? A U. And then from 1 up to infinity. In fact, I say this a lot. If you ever want to leave just one number out in interval notation, you do these back-to-back parentheses. That leaves it out. Does that make sense? Then that would just be all real numbers. How do you think we would say all real numbers in interval notation? That's right. This is everything. This is the smallest you can be, negative infinity, biggest you can be, infinity. That's all real numbers. Tell me how you feel. Right? Okay. Nah. Let's practice with some parabolas then. Let's go back. Let's say I have a parabola that has a vertex of 2, 4, opening down. What is my domain? All real numbers. And now I say that how? Left to right, my domain is all real numbers. How about the range? Bottoms up. What's the smallest y value on my graph? Negative infinity, because it goes down forever, right? What's the biggest? Bracket or parenthesis? A bracket. Why is it a bracket? Look at that filled in point right there. Beautiful. All of them, in fact, that's a great observation. All of them, in fact, will have the domain for all of your parabolas will be negative infinity, and the range will be based on the vertex. Either negative infinity up to the y part of the vertex, or the y part of the vertex up to infinity. Try something different here. Thank you. Right. I'll give you just a second to copy that down. What is the domain? All right, so smallest that x can be, the furthest left you ever go, is -3, right? Included or excluded? Excluded. It does not. So what does that mean? A parenthesis. Then what? Okay, well, since that's included and I keep going, I can just keep going through there. Why are you stopping at 4, Logan? Look at this. Look at this. That says leave that point out. So leave out 4. So I'm going to keep going right. This would be an issue, but it's bubbled in, so I'm okay there. But whenever I get here, as I move left to right, nope, it can't be 4, right? So I'm going to stop at 4. How do I leave just one number out? U and what? Parentheses. Back-to-back parentheses on the same number leaves out just one value. And then you go 6, that's exactly right, with a bracket. How about the range? So is range is bottoms up. Yes. So it's only leaving that value out for x. It's not, because here, do I have that point for y? Yeah, y could be -2 at all these points. So I have to include -2 for the range. So whenever I do -2, I'm going to do a bracket this time. Because even though this one's open, this is different. You have to understand what you're looking at. You're looking at what all can y be. Can y ever be -2 anywhere on that graph? Yeah, look right here. Y is -2. Y can't be -2 there, but it can be -2 here, so I have to include it. But then I start moving up. As I move up, I get, this is my first roadblock, right? Is it stopping me though? No, because it's included, right? And then if I look, I still got some graph over here. So I don't even have to stop. I keep on going up and up and up and up and up and up until I get to 2. That's my stopping point. Ooh, y'all didn't like that one, did you? That's it. Is this a function?
So we have, wait,
Oh, wait.
we had another point over there on 2.
Say that again.
I think we had another point, like another point.
Yes, yes. Correct, correct. If this kept going up and this point was, let's say, 8, 2, and it was bubbled in, yes, I would have a bracket there. Is it a fun? Why? What does it mean? The what? Every input has one and only one output. For every x, there's only one y that goes with it. Do y'all remember learning about functionality? So it is a function. I can take a vertical line anywhere on there and it never hits more than one time. So it is a function. As you copy that down, is it a function or not? Definitely a function. What is the domain? Yeah. We don't say it like that. We don't say it like that. We don't say it like that. Left to right, there's no place where x is not defined. Even if I come all the way out here on x, it's going up. It's going to be really high, but there's a piece of a graph that goes with it. Does that make sense? No matter where I go, there's a piece of a graph that goes with it left to right. How about the range? Bottoms up. Same thing for range. So I put all those points on there just to show you. Make sure you understood. It's tricky. It's tricky. Una más. Maybe. Function or not? Why? If I drop the vertical line right here, look, it would hit twice. This y value, this x value of -1 has two different y values that go with it. It would have the point like 1, 1 and or -1, 1 and -1, -3. That same x value has two different y values that go with it. So it's not a function, but that doesn't mean I can't do the domain and range for it. What's the domain? -4 to what? Brackets. Exactly right. Everybody see why? Left to right. So the furthest left I ever go is -4, and then the furthest right I go is 1. So I'm between, huh? It's not a function because I have a place, at least one place, where one x value has two different y values that go with it. Every x can only have one y. We do what we call the vertical line test. If you take your pencil and you run left to right, if your pencil ever touches more than once, it fails. This one is a function. That means your pencil, if you took it like this and went straight across, it would never hit more than one time. Right? This is slowly inching out, so there's nowhere that I could drop my pencil up and down where it would intersect more than once. But over here, all of a sudden right here, there's multiple places it would hit more than once. How about the range? I'll tell a story. Moss. Domain. Is it a function? Yes. Domain. Range. Just 2. That's the only thing it can ever be. So for this one, I would literally just, if you want to put it in, if you want to do like this, to say that it's just 2, or you can just say 2, y equals 2 for that. Whenever it just equals one number, you don't have to say, there's not really an interval notation for that. Okay, here's what I want you to do. I want you to go back before you turn this in, and y'all can take a break before you start, because some of y'all look like you're fixing it. Poor Hank is suffering. Charlie's eyes look very red. Y'all look like you're like struggling. I know. So I want you, before you start, I want you to get up, go get a sip of water, stretch your legs, go to the bathroom. But wait. Let me explain what you're going to do whenever you get back, so I don't have to explain it whenever you get back. Your group work that you did yesterday, I want you to give it to me before you leave. No exceptions. But 1 through 15, I want you to add the domain and range on the side of each one of them. So 15 domain and ranges. What's the domain on every single one of them? No, negative infinity to infinity, right? And then the range is either going to be negative infinity to the vertex or the vertex to infinity. Then I have your homework sheet here that you will have time to get through before you leave. For sure.